Okay, what we didn't get to was what our answer should look like if a function is requested. Okay. We know that typically implicit equations have derivatives that include x's and y's. We know like stuff like x squared plus y squared is equal to some constant that had the derivative negative x over y. We know this is not a function. Okay, I could solve for y. Y would be equal to plus or minus the square root of 9 minus x squared. This is also not a function because it has a plus and minus, which means if I plug in 1 x, I'll get 2 y's. If you have that, you don't have a function. However, pieces of that graph can be functions. If all of a sudden I change this to just positive root 9 minus x squared, then this is a function. If I plug in 1x, I'd get 1y. If I change this to negative root 9 minus x squared, that is a function. And its derivatives would follow this. So it would be a solution to the differential equation, and it would be a function, even though typically we're dealing with implicit equations that aren't functions, like circles, like ellipses, like hyperbolas. Okay? So what's interesting is that they will ask you to provide a solution to a differential equation that is a function. So they say, solve this in terms of y equals f of x. They are requesting a function. And they're telling you that y of 1 is 2. Well, let's see how that's going to work out. We know that the first step is to separate our variables. Oh, no. Let's see if this works. Okay. All right. We know we can separate our variables, multiply both sides by y, multiply both sides by dx. I get y dy is equal to 5x dx. I know the next step is to take the antiderivative of both sides. And once I do that, I have my general solution. We could have a plus c next to the 1/2 y squared. We remember that 1/2 y squared plus c. But I'd also have a plus c over on the right side. And those two c's can be combined to just be another c. Okay, this is a general solution. If you're asked to just find an implicit general solution, this works. We could graph this. If I had, you know, Wolfram or something, I could plug it into a program. They could graph it. I believe this looks something like this. Okay. Now this is not a function, but you know this isn't a function either. This is an implicit equation with y squared, which means if I plug in any x value, I should get 2 y's. Right? Well, they say you're asking for a function. They want a function. And you're like, well, that doesn't make sense because this isn't a function. How you can get a function? Well, we'll be able to just take a piece of it that is a function that does satisfy this initial condition, and we will say, hey, the derivatives still follow this 5x over y differential equation. So all we have to do is just be careful when we're doing it. So we're going to have to solve for y to get y equals something. I'll start by multiplying both sides by 2. I get 5x squared plus 2 times c. What's 2 times c? Just a c. Good. And then when I take the square root of something squared, this is where I get a plus or minus. Well, this is not a function. So this is not the answer that I want to get. Okay. First, I need to find c. So I'm going to go and plug in 1 for x and 2 for y. 2 will equal plus or minus root 5 times 1 squared plus c. I can actually just figure out what c is by looking at it. C is going to have to be -1 because the square root of 4 is 2. Okay, so I know c is -1. So that helps. But again, still not a function. We still have the plus and the minus. We need to pick the correct piece of it, though. We need to just pick whether we have the plus for this situation or the minus, and that piece will follow this differential equation and satisfy this initial condition. Okay? So if y of 1 is 2, 2 equals plus or minus root 4, what do I need? The plus or the minus in front of the square root? The plus. So I'm going to select the plus, get rid of the minus, and I have now a function that satisfies the differential equation and the initial condition. Now we have a function because there's no plus or minus. If you ever requested a y equals f of x, that's a function. So you can't have a plus or minus. Okay, so it's just one little difference between this and the previous problems. It's just we didn't have time to talk about it, and I didn't want to confuse you too much. So let's do one more, and then we'll go over the homework. Why don't you do this one? And you want to solve this differential equation in terms of y equals f of x. It's a good practice problem to prepare ourselves for something we might see on the quiz. I could really plug in the 1 and the -2 at any point here. So don't be afraid, and sometimes in the book you'll see in the answers they'll find C earlier rather than later. 8/3? 7/3, sorry. So y squared is equal to 5/3 x squared plus 7/3. Take the square root of both sides. I'll get plus or minus root 5/3 x squared plus 7/3. I look at my initial condition. I first realize that I have a plus or minus, so I don't have a function. I look at my initial condition. Turns out they only want us to know that y of 1 is equal to -2, even though y of 1 could have other values. So you could have the 0.1 -2, and you could have the 0.12 on the graph of this, which probably is the case. But they just want the piece that has just this point. So for this to be a negative value, I need this negative here. And this is my function. This is the piece that follows that differential equation and satisfies that initial condition. Okay? Function. All right, let's go over the homework. Okay, more differential equations of things that started like backwards implicit differentiation, I guess. I want to say like implicit antiderivation, but it's not. It's just a technique that we use. It's called separation of variables that helps us to take a differential equation like this and solve it. Okay, so we're going to just be doing more of these. That guy, that guy, that guy, that guy. Only it's going to be a little bit harder, and the answers are going to look very specific. We're going to want our answers to look, be in the form of y equals. We'll see our constant of integration is not going to be where it usually is. Our plus c is going to be in different spots. So first thing we need to talk about before we start these different differential equations and solving them is we need to review some things about exponents. So if I have x squared times x cubed, I know, and I always tell my algebra students, when in doubt, write it out, that's a total of 5 x's being multiplied together. And through that, they can generate the rule that x squared times x cubed is really x to the 2 plus 3. This is a true statement. Well, what we're going to need to know for today is that if you start with something like that, you should be able to go the other way around. So if I have x to the y plus 5, I can rewrite this as x to the 5th times x to the y, if I want to, or x to the y times x to the 5th. Okay, e to the x times e to the y can be written as e to the x plus y. Well, guess what? You'll be able to go here backwards. So if you have like 5 to the x plus y, I'll change that from a 2 to a y. You can write this as 5 to the x times 5 to the y, or the other way around. Okay, so that's first. Second, we need to remember how to solve for certain variables in certain situations in powers of e or in a logarithm. So if I want to solve for x in this equation, e to the x equals y on the left, what do I do to get x by itself? Yeah, you take the log of both sides. So you will literally just say log and log on both sides. Logs and e's undo each other. They're inverse functions. So what happens is they go and cancel each other out. Just give you x. Log of y is just the log of y, whatever that may be. But we just solve for x. Now, if I have the log of k is equal to L and I want to solve for k, how do I release k from the clutches of the log? Yes, e to the power of both sides. Now, that's going to be like that. I usually put the carets just so I know that it's not e times, it's e to the power. Now, just like log and e here, giving us x, e to the log, k, is just going to be k. They will undo each other. And this is e to the L. Okay? You probably didn't learn, you might have learned this that way, like in pre-calc and algebra 2. But some teachers use like a rewrite method, and I don't know, it gets confusing when you're rewriting. I just like this. I feel like it's algebraic, and it is. It just makes sense. So this is what we do. Okay? Now, we will have to solve for y, and y might be in a log, or y might be in a power of e. So we need to be prepared for this. So let's look at the first one here. If I wanted to solve for y, and it's in log absolutes, I would take e to the power of both sides. On the left side, I would just have the absolute y. That would stay. On the right side, it's very, very important to put this entire thing in the power of e. You don't do one power at a time. It's not e to the 5x plus e squared. That's not correct. This is e to the 5x plus 2. That's not the same as e to the 5x plus e squared. That's not right. Okay, so this is correct. This is fine. We just solved for y. We'll see how we'll be able to take away the absolute value in a second. But what we'll also be able to do is rewrite this so that I don't have the plus in the exponent. I can rewrite this as absolute y equals e squared e to the 5x plus, just e squared e to the 5x. We'll find out that we'll take this like 2, it's e squared. Yes, you usually write it like e to the 5x times e squared, but we'll want to bring this out in front for a reason that we'll see in a little bit. Okay? And then this absolute value, what's really interesting is that we don't need the absolute value in this situation, because no matter what x I plug in, this is going to be positive, because e to the x is always positive. So this is just y. Okay? We could have something like this, e to the y equals 4x squared plus 2. I'm thinking about that previous problem. Hold on a second. X is -3, and the log. Oh, no, that's fine. Yeah. Why would this be? A decimal. Okay, for this guy, all you would do is log both sides. Now when you do it, you log the entire right side. What you'll see is that you might have like a C in here. You would put the C inside the log. This would just be y is equal to the natural log of the quantity 4x squared plus c. The c no longer is there, is outside or being added, you know. Okay, so if we can do that, if we remember those properties, we're going to be good to solve these differential equations. Okay, we're going to want to solve them and leave our answers as a y equals equation. This is just a couple extra steps. Okay, step 1 to solving a differential equation with x's and y's is what? Mr. Brewer. What's step 1 to solving that differential equation?
You separate the two.
Yes, you separate them. Now, do you just move stuff magically, or what do you have to do?
Take y over the fucking derivative y.
So how do I take y over? Is it going to be y dy?
Yeah.
Make sure you don't forget that you have to move things over algebraically. I'd have to multiply by 1 over y to get rid of the y. I'd have to multiply by dx to move the dx. So algebraic manipulation of that to separate your variables. Now we're ready for step 2, which is to take the antiderivative of both sides. Everybody go ahead and do that. Then pause, because a lot of you are going to make the mistake that I know you're going to make. I'm just looking at everybody's. Good. You're taking the derivative in the 6. Nope. That's the mistake everybody makes. Good. On the right side. Good. You'll get there. Yep. Just x. Yep. Don't forget the absolute. That's good. All right, not many of you. That's good. Not the 2. You don't need the 2. It's add 1, then multiply by the reciprocal. Remember, only use the rule for 1 over x if it's 1 over x. This is log absolute y. This is not log absolute x squared. You use the power rule for anything other than 1 over x or 1 over y or 1 over u. This is x to the negative second. The antiderivative, you'd add 1, multiply by the reciprocal. Yes, you'd have a plus c on the left, but you have a plus c on the right. You combine the plus c's. Okay. Well, this is good. This is actually, a general solution. If they just asked you for a solution, a general solution, you could have given this. But they don't. They ask you for a particular solution in the form of y equals. So we have more work to do. Well, let's start by trying to solve for y. I'm going to walk you through this one. I'm going to show you every single step. I will then show you how you can skip steps in the future, but only if you understand the every single step. So we're just going to do every single step for today, and then you can start skipping. Step 1, let's get y by itself by taking e to the power of both sides. This leaves me with the absolute value of y is equal to e to the entire right side, including the c. Now you can rewrite this as negative 1 over x plus c. Now, I can rewrite this e to the negative 1 over x plus c as e to the c times e to the negative 1 over x. That's that exponent property we talked about at the beginning of class, beginning of the lesson. Well, what's e to the c? It's just a c. Yep. It's a c. It's got to be a positive c because e to the c could be positive, or e to the c is positive. It will always be positive. E to any power, a number to any power is always positive if that number starts out as positive. Okay? Well, guess what I can do now? If this is positive and this is positive, the y typically is going to be positive. However, if I wanted to kind of assign, like if I deal with negative y's, you know, and make it positive, I can kind of assign like this c either positive or negative values and get rid of this absolute. So I can make this like a plus or minus c e to the negative 1 over x, which is just a c. Well, here is my general solution. Y equals c times e to the negative 1 over x. I can then plug in my initial condition. Y of negative 1 is 3. I get 3 is equal to c times e. C will just be 3 divided by e. Giving me my particular solution. Voila. Lots of work for every single problem. Now, in the future, I don't want you to do it today because I want you to understand these steps today. In the future, you'll be able to skip all of this. Once you understand that you'll have e to the something plus c, and then you can bring it down and make it e to the c times this, and you know that this is a c, and you know you can assign it a positive or negative value instead of just being positive. Okay? Once you know that, you'll be able to go right from here to here. Okay, so let's practice. Let's solve this differential equation for y. Any questions? Any snags? Any hiccups? Any misunderstandings? Check your answer with the neighbor. Okay. Here's your answer. Here is the stuff you will be able to skip in the future. Any questions? Issues, problems, so far so good? Just keep going then. The way we'll really get good at these is just by continuing to do them. Oh, I wanted to change this. Pause. Sorry. Hold on. What if this was 2 minus y instead of y minus 2? What would that change? Is the antiderivative of 1 over 2 minus y log of 2 minus y? No. What do I need? A negative. Why do I need that? Well, because if I took the derivative of this, it'd be 1 over 2 minus y times the derivative of y, which would have been negative 1. You have to use U-Substitution if you really, really do want to see it. You would set u equal to your denominator. Du would be equal to negative 2 dy. So you'd have 1 over u, but then you'd have that negative 1 that you would need. And that should be a du. So there's that. So now that that's cleared up, how can we solve for y? First step, get rid of the negative. Don't take e to the power until you just have the log by itself. So multiply everything by a negative 1. Now, the c would become a negative c, right? Do I need it to be negative c? It's just a c. So leave it as just a c. Step 2, now that the log is isolated, we can get rid of it by taking e to the power of both sides. Simplify some stuff. We got to get rid of this absolute value. So we have e to the c. I'll kind of move over here to show you these steps that would go into this. E to the c, e to the negative x cubed. This would be c, e to the negative x cubed. This can go away to give you just 2 minus y equals c e to the negative x cubed. Almost there. Subtract 2, multiply by negative 1. The negative would get baked into the c again. It would still remain c e to the negative x cubed, only I would have a plus 2. Okay, now we have our initial condition. We can plug our initial condition in to find c. Once we found c, we may use the y equals equation to find y when x is 1. So 0, 7. Would give us a c of 5. That was when you run out of space. Plug in 1, you get 5 times e to the negative first plus 2, which can be written as 5 over e plus 2. This is y of 1. Okay, good. Let's do another one. First step, the most important step, is to separate these variables and to do so algebraically. Really, we just got one y that I got to get rid of, and then I can move the dx over. How do I do it? And just divide by y, or multiply by 1 over y. That will cancel with this y up here. Totally cool. Ready to go from there. Need to use U-Substitution for that right side. Okay, we can take e to the power. Let's make sure we're here. Log of y equals 1/2 log of x squared plus 4 plus c. Show you what we can do from here. So if I take e to the power, I just have absolute y. This is e to this entire thing. That's fine. We kind of want to get rid of this absolute y, so I need to bring down this c and assign it that positive or negative value. So that's e to the c times e to this, or just c e to this. Mr. Bonner. Good question. It's about to, but it can't right now because of the 1/2. If it was just e to the log, then yes, it would cancel. The 1/2 complicates things, but we're going to be able to do it because of what's going on there. We have e to a product of powers, really right next door, right here. Let's recall, and this is more exponent properties if you want to do it. If I have x to a product of powers, what is another way you can write x to the 2 times 3 besides x to the 6? Exactly. A power to a power. Well, if I have e to the 1/2 log x, or log of something, I can rewrite this as e to the log x to the 1/2. Aha! Now I can cancel the e and the log to give me that this is just the square root of x. So let's see what our guy would simplify to. We did that. This would be y is equal to c e to the log absolute x squared plus 4 to the 1/2 power. E and the log would cancel, giving me y equals c root absolute x squared plus 4. Awesome. Right? Do that one. While I hand out half of your homework. You have book problems and you have AP free response problems. 1 through 4, not this entire packet. But we got to do this one first. This one's a good one. And I'm going to show you, probably on the video, one more example that is actually a problem in your homework that you have to do. So, watch that. Okay, step 1, separate your variables. How the heck can I separate those variables if it's e to the x plus y? E to the x times e to the y. Okay. That's a good start. Step 2, separate your variables. You would get 1 over e to the y dy is equal to e to the x dx. Ready to antiderive both sides. Well, the antiderivative of e to the x is just e to the x. What is the antiderivative of 1 over e to the y? What's that? Is it just y? No. Negative e to the negative y is correct. How did you get that, Miss Quinn?
I subject the negative y whenever you have a negative variable. I don't know.
Yeah, it's the whole backwards thought. Yes, it's one of those things where it's like, okay, the derivative of negative e to the negative y is e to the negative y. If you can't see that, you could use U-Substitution and you set u equal to negative y and you would see that this would be the answer. Well, that's this. Well, now I got to solve for y. Multiply everything by a negative 1. Take the log of both sides. The log and this e would not cancel because I have this plus c in here. We have to write it like that. And then apply the negative again. And this is my general solution. All right, there'll be one more example that will help you on your homework. So I'd watch that before you do your homework. I'm going to finish this one up as well. Y of 0 is negative log 4. So negative log 4 is equal to log of negative e to the 0 plus c. Sorry, negative. That's a negative. So negative log 4 will equal negative log. This would be negative 1, not 1. So that means c would have to be 5. All right, this is problem, I believe, number 2 in your homework. It's talking about the rate at which a baby bird gains weight proportional to the difference between the adult weight and its current weight. At time t equals 0 and the bird is first weighed, its weight is 20 grams. B of t is the weight of the bird, then dB over dt is equal to this equation, where B is the weight of the bird. We're asked to use separation of variables to find y equals B of t, the particular solution to the differential equation with the initial condition B of 0 is 20. So we need to solve this differential equation, which is dB over dt. This is the derivative of the weight equation B of t, which we don't know. So we're going to find B of t. So what I would do is separate variables. Now how I would separate variables is by dividing by 100 minus b, and then just leave the 1/5 over here and multiply both sides by the dt. Now when we take the antiderivative of both sides, the antiderivative of 100 minus b, so you'd use U-substitution to see that you need a -1 out in front. Du would be equal to -1 dB. So dB is equal to -1 du. So this would be like 1 over u, -1 du. Antiderivative of that is just log absolute of u. And that's going to be equal to 1/5 t. Now, they want y equals b of t. So they want us to solve for b, and we want a particular solution here. So I'm going to really solve for b to have like b of t, which could be equal to some y. Start by taking e to the power of both sides. Of course, I have a plus c here. Don't forget the plus c. That gives us absolute 100 minus b equals e to the 1/5 t plus c. Bring down the e to the c, and you can get rid of the absolute value to make this c e to the 1/5 t. Subtract 100 multiplied by -1. B would be equal to c e to the 1/5 t plus 100. So there's your b of t, which is your y equation, and now we have b of 0 is 20. So 20 is equal to c e to the 0 plus 100. So c is equal to -80. So b of t is equal to -80 e to the 1/5 t plus 100. Okay, so that's your homework problem. I worked through it the entire way, so you can just copy it down. Hopefully you try it yourself, and then you make sure you got the right answer. Thanks.